Okay, so welcome to all participants. A very good evening to all of you. I'm Vineet, Principal Data Scientist here at Square Circle and a Minitab Certified Trainer for Middle East. I'm pleased to host our second expert talk, which is Value Stream Mapping Application Overview today. Just want to quickly run through the agenda. So we are going to have a short introduction about us. There will be a basics of VSM for like 10 minutes. We'll be explaining you that. And then we have a special guest and we will be introducing him to you. And he will be sharing some great insights about value stream mapping. So he will take us through a quick exercise also on drawing VSM and benefits of VSM. If you have any questions, during the webinar, please type them in the chat box. If we get time, we will answer you after this webinar, like in the end, or we will send you an email after this webinar, specifically for your problem. Okay. So we will ask you to unmute and this is how the question and answer will work. So let me go next. I'm pleased to introduce our guest speaker today, who is Nilesh Rathod. He is a regional manager, Lean Six Sigma at Henkel. So why don't Nilesh, can you come and please introduce yourself? Yeah.
Yeah, thank you, Vineet. About myself, I'm a certified Lean Six Sigma professional. I'm certified Six Sigma Master Black Belt, and I have more than 12 years of work experience. Currently, I'm located at Dubai, working with Henkel. It's a great meeting you all, you guys, and giving an opportunity to introduce value stream mapping topic.
Okay, thank you, Nilesh. So I would like to give you a quick intro on Minitab. So Minitab is a world leader in statistical analysis. It's a solution analytics company where they have a range of products, and the most popular one is the Minitab, which is a statistical analysis tool. So we have currently version 19, and then this October 21, the Minitab is going to launch Minitab version 20. So you can join. We will send you the link if you want to join that webinar. And it's going to be released on October 21st. Okay. So Minitab has created a stream of different products. So here you can see the next one is the Salford Predictive Modeler, which is a machine learning and predictive analytics software from Minitab. Then there is Workspace. Workspace helps you to visualize some of the Lean Six Sigma tools, such as 5S, or you have something like this VSM, value stream maps. If you want to make process maps, all of such things can be drawn on Minitab Workspace very easily. Then we have Companion, which is a project management tool, and you can manage all of your project management initiatives from Companion very well. It integrates with Minitab as well as Workspace and like any other tool. So you can control your all Six Sigma projects from Companion at one go. It's a cloud-based software, so all of your teams can share it. Then we have a Quality Trainer. It's a online based statistical training tool. It has a lot of quizzes. If you like to train yourself on statistics, you might want to learn through Quality Trainer. On the services side, we have a bunch of services we help our clients with training, from any kind of statistical training to quality trainings or any kind of Six Sigma training. We help with them any kind of consulting work if you want. We help with that, and then we do have support system. If you have any issues while installing any of these softwares, Square Circle does help you with that also. So this is a little bit, we work with a variety of clients across the GCC region and globally also. So this slide just talk about some of our clients. So I'm pleased to mention these clients like Emirates, Walmart, EGA, and a lot of others. So today's session, it is power packed with Nilesh's knowledge on value stream maps. And but before I hand over to him to explain you the value stream maps and how to make it, I want to launch a quick poll before we go. So this poll is, we would like to know, does your organization use value stream maps for material flow representation? You will see a poll in your screen right now. I request you to please vote. I will wait for another 10 seconds for you to. Yeah. So I think one or two more people want to give answer. Does your organization use value stream maps for material flow representation? So I think 70% have some. We have 70% people who have voted, and most of them, uh, it's a kind of 60-40 ratio. 60% of you are not using it, and then 40% of you are using it. Okay, so let me launch this results. Share results. So you might be able to see the results now. It's like 64 and 36. Okay. Okay, so I believe this session is very important for you because from the poll result itself, we see people still are not using a kind of value stream maps. So Nilesh, it's up to you now to
Yes.
explain them and why it is so important. Okay, and let me just go to the next slide. So I'll now hand it over to Nilesh. Nilesh, please, yeah.
Can you see my screen?
Yeah, can you go one slide back? Okay, okay, yeah, yeah, it's okay.
So let's start with the value stream mapping. Value stream mapping is one of the powerful tool of a lean manufacturing. So in a given setup of operation management or on the shop floor, the current processes are made of full of wastages, variation, problems, constraint, non-value added activities. So value stream map helps to identify what are the problems are there, what are the waste are available over there, what is the variation, what is the bottleneck, what is the constraint over there. And by using appropriate lean tool, we have to eliminate this wastage, these problems, this issue. And we will reach to a future state map or future state which will be smoother, faster and safer, which has a maximum value added activity compared to the previous one. So this is a philosophy of value stream mapping which identifies the waste in your processes. So it is an area of opportunity. So value stream mapping in a nutshell, it is a uses of lenses which identify the waste across our processes. So this is explained very well what is a VSM approach. So you can see here there are two pictures. In first picture you can see individual efforts. So this is a board and there are 5 operators which has a blades. So if you look at the number of blades are varying operator to operator, and if you look at the timing of exerting the forces are also different. They are not synchronized. So what will happen? Result, they will not get the desired speed, and at the end they will not achieve their targets. If you compare to the second scenario, there is a boat, all the 4 operators are having the same number of blades, and if you look at the timing, they are synchronized at the same moment. They are exerting the forces and resulting in they will achieve the desired speed. And there is a one guy who is guiding them at what time they should exert the force, and result in they can get the optimum speed from the given resources. And same thing happen with our processes. Our processes at a lot of workstation, and that workstation has a bottleneck, some has a less speed, some has a higher speed. So looking at this value stream mapping approach, we have to optimize our resources, we have to optimize our speed, and we have to get We have to try to get maximum velocity, maximum flow from the our operation setup. Moving next, so there are 8 deadly waste always present in our processes. And what are these 8 deadly waste? Earlier it was known as the 7 deadly waste. Now they have added new one more waste known as a skill. So let's have a look at each and every waste. So first waste is the transportation. Because of poor layout, when forklift or any material handling equipment travel from one location to another, it leads to a transportation waste. Unnecessary movements of material handling equipments are lead to transportation waste. So the reason is poor layout. Next is the inventory. Inventory always lies in 3 phases: raw material, work in progress, and finished good. So inventory is one of the biggest waste compared to out of this 8 waste, because it eats your profit and it is as good as your money. Third waste is a motion. Excessive movement of human body movements are known as a motion, which can be eliminated by using ergonomics or work measurement tools. Fourth is a waiting. So waiting for any kind of information, any kind of confirmation, raw material, or any kind of instruction are nothing but the waiting waste. Fifth is the over processing. Delivering excess than the customer requirement leads to over processing. Six, overproduction. Producing more than the requirement, or producing earlier than the requirement, or doing work before it is needed. It is overproduction. Seventh waste, that is known as a defect waste. Any kind of activity which has a rejection, rework, or defects are falls under the category of defect waste. Last, skills or creativity. Anything which is not using human creativity or human skill up to their fullest ability are fall under the category of skills. Next, always remember the five golden rules when you will perform the value stream mapping. So you should not draw a value stream map sitting at your office or a conference room. You have to go to Gemba. Gemba is a Japanese word which symbolizes the real place, the actual place where your processes are happening. So go to Gemba, number one. Number two, observe the real thing. What is happening over there? Don't assume based on your flowcharts or the data you got it. Go to Gemba and observe carefully what is happening over there. Okay. Third, get the facts and data verified. If you got the data which shows the changeover time or cycle time, whatever, but you have to go and verify whether it's actually happening or not happening. If your process says something else on the your documentation, but in reality it may be different. So go to Gemba and observe these things and get verified the actual things. Fourth and very important, that is a continuous improvement attitude. If you believe that this process can be improved, then the chances are very high you will apply your creativity and you can improve the things by using a small improvement that is known as a kaizens. Fifth, involve the teamwork for the better idea generation and for the support, whatever the project you will identify through value stream mapping. So these are the 5 golden rules for the success factor. Next, application of value stream mapping. So value stream mapping was started at Toyota car manufacturing company. It was automobile sector. Now slowly it was developed in many manufacturing industry. Now it was adopted similar approach, similar basics in the process industry as well. After that, it is implemented in service industry as well. So you take an industry, it is available everywhere, like a shipbuilding, aerospace, consumer product, industrial products, pharma, food industry, chemical industry, airlines, banking, BPO, consulting, hospitality. So people are aware that it is very well applicable in manufacturing. Let's take an example of banking, how you can apply the value stream map in a banking sector. Yes, it can be easily applicable. So let's take an example of one consumer who enters inside the bank and he has some work, maybe some transaction with the cashier to take some money or to deposit some checks, and how much time it will take from entering inside and going outside. So that time and that all sort of activity can be mapped, and you can understand where is a maximum time consuming, where is a bottleneck, where is a it waste lies in this process. So you can similarly apply these basics in all industry, and they are getting a benefits hugely. So that's why value stream mapping is very popular in all the industry to identify these 8 waste. Next, Vinit, can you open the poll? So you will get a 30-second, and you have to say from which industry are you belong to, either manufacturing or process or service industry.
So please. So 50% of you have responded. Yeah. Okay. 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 So if your company belongs to two groups, tell us which one do you work for? You might have several areas.
There
So
are 4
Rajesh.
participants hasn't voted, so there are
Okay.
last 10 seconds. Can you vote it?
So it's yeah. So it's okay. I think I'll end the poll here, and
Okay.
let me share. So it is like 65 and 18, 18. You can 64, 18, 18. So most of you belong to service industry here. Let me share the results. So you should be able to see it. So most of 64% of you, the participants belong to service industry, 18% to both process industry and manufacturing industry. So that's okay, quite good to
Great.
know. Thank you. Uh, Nilesh, you can continue. Can
Yes.
you remove this info from the screen?
Okay, so this was the basic. Now we are moving to one case study which I will explain all the basics and the terminology, symbols, notation used drawing in the value stream mapping. So there is one
Nilesh,
hypothetical case.
Nilesh, there is some window which is open on right hand side of your screen. Can you see that? Is it there? Yeah, yeah, this one.
Okay.
Yeah, that's okay. That's one.
So today I'm explaining one hypothetical case known as the Acme manufacturing. So this is a hypothetical case, but by using this case study, I'm going to explain you what are the various symbols, notation, protocols, or what are the steps to be followed in a drawing of value stream mapping. It is very difficult for me to explain you within a short span of time. Normally it takes 1 or 2 days of workshop to explain everything in detail, but still I'm trying to explain in by using an animation what are the steps followed for the drawing a value stream map. So these are the 4-step methodology. First, selection of the correct product from the your ideas. Suppose your company is manufacturing 200 various products, so you can't draw value stream mapping for all the products. You have to select a single product which has a high volume or high business in terms of money. Second, you have to draw a current state map. That product goes through various operation stages, so you have to map that material flow of that particular product. Third, drawing a future state. Future state is nothing but your ideal state, or it is a blueprint the way you want in your future. Fourth, from moving current state to future state, there are so much opportunity, there are so much gaps, there are so much wastage, there are so many non-value added activities. So you have to identify, and in step 4 you have to implement how these gaps can be bridged. You have to implement the solution for that. So these are the 4-step methodology, and it is very important to step by step you have to follow all the stages. Always start always start by mentioning your producer name and detail about it. So here Acme stamping is a producer which produces the steering bracket. It is one of the component goes in the automobile sector, and this is a current state map we are drawing. Second stage, mention the customer details. For a customer, always use a factory icon, and mention the customer name inside that. So who is the customer for the Acme? There is a state street assembly. And below that, there is a data box which cover the characteristic or the information for this customer. So what is their information? They required 18,400 pieces per month. And out of that, 12,000 pieces are left-handed, and 6,400 right hand. Means there are two variants of these two pieces, left side and right side. And they want the pieces, 20 pieces per tray, means 20 pieces should be packed in one packing, and they are working for the two shifts. So this is nothing but the customer detail. So first stage, capture the customer detail. Second, look at the what is the frequency they are looking at. So they are looking for the shipment, daily shipment. So if their requirement is 18,400 and they are working for 20 days, it means they require almost 920 pieces per day. So this Acme has to produce 920 pieces per day, and they have to ship that every day. Next stage, now you have to draw a material flow, and material flow always you have to draw from the right side to left side. So here it is my last workstation, that is the shipping station, then assembly 2, then assembly 1, spot weld 2, spot weld 1, then stamping. So always draw a material flow from the right side to the left side. Now these boxes are known as process boxes. So in the process boxes, you have to mention the name of the process, and below that mention the information and characteristic about that process, and this is known as a data box. So you can capture as much as you want, but normally 3 or 4 characteristics always capture, like a CT stand for cycle time, CO stand for changeover time or setup time. Next is the uptime, nothing but your available time, number of manpower deployed at that particular workstation. You can additionally capture the number of defect or OE or defect rate or rework rate, whatever. But remember one thing, whatever you are capturing here in data box, it should be same for remaining all the workstation. So here say cycle time 39 seconds, changeover time 10 minutes, uptime 100%, and manpower is 1. So you can see the characteristic described for stamping is same for the spot weld done, but the data will be different. Why we are capturing the same standards? Because we have to compare this, and we have to identify which workstation takes maximum number of people, which workstation has a maximum changeover time, which workstation is the fastest, which workstation is the slowest. So this is what we have to identify. So now in this way we can complete our material flow, but before that we have to identify the non-value added activity. So one of the best is a inventory, and that inventory is shown in this icon, the triangle. Inside the triangle there is a eye, so this symbolizes inventory, and below that you can mention the inventory lies before the workstation. So this way we can mention the inventory available at every workstation. So before spot weld 1, there is a 4,600 left hand sided bracket and 2,400 right side brackets. Similarly, for before spot weld 2, there is the inventory. So every workstation has the inventory, and which is shown by this triangle, and below that you can mention the inventory available. So always remember, you have to mention the inventory number of pieces at the bottom, not anywhere here. And icon of inventory should be mentioned before the workstation. It symbolizes that the inventory available before this workstation. Now moving further, so this complete your material flow, which start from the stamping and ends to the shipping. It means you get a raw material here, and at the end you will get the final finished product. So this completes your material flow. Now let's move to the information flow. For information flow, we required a customer. The customer input goes to the production planning team, and which further goes to the supplier. So who is our vendor or supplier? So Michigan is our supplier, which produce coils, and every twice in a week, Tuesday and Thursday, they are supplying the raw material. So this is a shipment, whereas this is a shipment from our shipping department to the customer, and this is the vendor who is producing the coils, which is supplying twice in a week. Now let's complete the information flow. So information flow always mentioned at the top of the value stream mapping, and material flow always mentioned at the bottom of the value stream mapping. So now let's try to complete the information flow. So this is my production planning and control department, which gets the info from the customer, which is saying 30 days, 60 days, and 90 days forecast to the our production planning control team, and our PPC department giving 6-week forecast to the supplier. After that, they are sending the orders. So customer is placing a daily order, whereas our production planning control team sending the weekly facts to the vendor. So now our PPC department run the material requirement planning, and based on that they understand how much material to be procured from the vendor, and based on that they will send the weekly packs. At the same time, looking at the availability of the material, they will have a weekly schedule, and they will provide schedule to each and every department. So here you can see the arrow. They are asking stamping to produce this much of amount of pieces, spot weld 1, spot weld 2, assembly 1, assembly 2, etc. At the end, there is a daily shipment schedule given to the shipping, so that every day you have to produce 920 pieces and have to send to the customer. So now this way you can complete your value stream mapping. Now look at there is one more element known as a push process or pull process. When you are producing as per the requirement of PPC, that process is a push. If it is a pulled by the customer, that process is known as a pull process. So here in the case Acme, all the processes are push process, means you are pushing the product in this way. It is not pulled by the customer, whereas it is a push by the each and every department. So this is the icon, which is a stripped icon with a zebra crossing marking. So that's known, this arrow is known as a push process. So now this completes your value stream mapping. Now you have to summarize this value stream map with the value added ratio and non-value added ratio. So now how I can summarize? So summary, you have to do it at the bottom of your value stream mapping. So customer requirement is 920 pieces per day. So can I convert this inventory into number of days? Yes, I can do. See, 4,600 are the left-handed pieces and 2,400 are the right-hand pieces. So if I calculate in number of days, means it is a 7,000 divided by 920, it will come as 7.6 days. So equivalent, I can calculate for all the workstation how much inventory is lies. So now I will calculate the summary of non-value added activity, because inventory is nothing but the NVA. So 5 days, 7.6 days, 1.8, 2.7, 2 days, 4.5 days. So these are the non-value added activity always mentioned at the crust of your wavelength, and at the bottom of or trough of wavelength you will mention the value added activity. So value added activity is nothing but the cycle time. Okay, so now you will wonder the inventory is in number of days, whereas the value added time is in second. Yes, it's true. So this completes our value stream map, and which conclude my production lead time is 23 days and my processing time is a 188 second. What does it mean? It means when the customer place an order, he will get his material after 23.6 days. And what is mean by processing time is 188 second. It means to manufacture one piece, it will take only 188 seconds. Are you getting this? So if you calculate the ratio of value added to non-value added, it will be less than 1%. And this is the reality. And we have to improve our value added ratio. That is nothing but the ratio of processing time to production lead time. It is in seconds, whereas it is in days. So what are the opportunity? You will find that opportunity is nothing but the Kaizen burst or the area of improvement. Okay, so this area of improvement has been highlighted here in the red boxes. So what are these possible improvement we can see here in this current Acme stamping manufacturing setup? So number one, I can see there are two workstations, spot weld 1 and spot weld 2. Can I optimize because of the similar nature of work? Yes, I can do that. Assembly 1 and assembly 2, there are two different workstations. Can I optimize that into one workstation? Yes, I can do that. Here in the workstation of spot weld 2, the uptime is 80%, which supposed to be 100% ideally, but which is the 80%. So can I improve my uptime? That is a availability of machinery time. Yes, I can do that. Then all the processes here you can see, or push process. Can I convert from push process to pull process by using a supermarket or FIFO concept? Yes, I can do that. So this is what the area of opportunity I have identified. So based on your team, you can identify the different opportunity based on your team meeting or team ideas generation workshop. So after that, I will get a future state which will be faster, smoother, and safer. So here, yes, earlier there was a 6 workstation. Now I have only 3 workstation. Earlier there were 6 people were working. Now there are only 4 people are working. Wow, great. Earlier my 23 days was a non-value added time. Now it is a 5 days. So my lead time is a 5 days. And earlier it was 188 second my processing time. Now which I have reduced, crunched to 166 seconds. That is unbelievable. And this is what my future state, where I have improved my processes, where I reduce my inventory, where I optimize my number of processes, where I optimize the number of people, everything. So this way you can draw the future state and you can enjoy the journey of continuous improvement in the plant. Now, what are the benefits of value stream mapping in nutshell? It creates end-to-end view of a system. So sitting and understanding the bottleneck, how you can satisfy your customer. So this is the end-to-end map. Next, it demonstrates the interaction between the material flow and information flow. If I divide this value stream map into two halves, if I cut this value stream map into equal halves, so upper part is known as the information flow, which flows from the customer to the supplier, and the bottom part known as the material flow, which start from the raw material to the shipping or the final packaging department. So this demonstrate interlinking between the information flow and the material flow. No other tools explain so beautifully what value stream map demonstrate. Third, it provides a common visual language for understanding a complex system. If you want to do an improvement at a multiple workstation, so value stream mapping is a very well-known tool. Next, summary. So what we have seen, the basics of value stream mapping. What are the steps involved in drawing the value stream mapping? There are the 4 steps. We have seen that, and 5 golden rules for the critical success factor. What are the 5 golden rules? Go to Gemba, observe the real things, get the facts verified, continuous improvement attitude, and last, that is the teamwork. Over to you, Vinith.
Thank you, Nilesh. So let me just start sharing my. So I think you all have seen where we have now. So I'm just quickly making a value stream map before you. Okay. So we have identified here the Kaizen burst and then the future state map. Okay, thank you, Nilesh. So this chart you can make it in Workspace. So I have generated this in Minitab Workspace. This is one of the tools, as I said, where you can make several visual tools, lean tools. This is just one of them. So before we end, I'll quickly go through poll 3. So I just wanted to know how effective was this webinar to you. So I would like to know what is the most important outcome of the current state in VSM. So let me just pull the poll out. Yeah. So I request you all to answer the poll 3. Yeah. Okay, I'll wait for another 10 seconds for rest of you to. Before I end poll, can you all please submit your answer? Yeah. Okay. Okay, I'll end the poll. So the actual is this: we are the most important outcome is to highlight and eliminate the sources of waste. So we have around 70% people who are correct. So I believe 1% has said to identify production capacity, and one is saying to allocate resources. So for you, actually, this is to highlight and eliminate sources of waste so that we can make a future state map and then reduce our waste. Let me share results. So you might be able to see the results. Yeah. Okay. And so if you have any questions, kindly can you please write it down in the chat box? Let me see. Samir Faril is saying for me all, but yeah, I'm saying most important. So there was one question during the Nilesh. There was one question: what is uptime from Samir Fadel? But I think Nasim has already replied to him with the what is actually uptime. So I believe the he has given the right answer. Yeah. So
Yeah. So takt time is nothing but the rate at which customer demands your products. It is nothing but the available time and requirement of number of pieces or number of requirement. Suppose you are a car manufacturer and every day you have 8 hours of work. Out of that 60 minutes, suppose you are for a lunch break is there. So available time is say 420 minutes and the customer is asking say 420 cars per day. So what is your takt time? Available time is 420 minutes and number of cars is 420. So they are asking each car at a rate of 1 minute. Means you have to understand the customer requirement. They are asking each car at 1 minute, means 60 seconds is your takt time. Accordingly, based on that, your setup, production setup should deliver each car should be within a 60 second. So that is the takt time. And based on that, you have to synchronize your all workstation that should be able to produce cycle time less than 60 seconds. So that is about takt time. And it is a good question.
yeah.
Because of constraint of time, I have not covered the takt time and many concept related to that. Just I have given an overview about and feel about the value stream map, how what are the steps are required. So
So there
thank
is
you
a
for the
question
question.
from Nasim about the Minitab workspace. How fast is it compared to sketching with a pencil eraser? Definitely, pencil and eraser are faster, Nasim. Even I believe so. But yes, in terms of sharing across like team on the web, on the cloud, then Minitab workspace is much better. You don't need to take photographs. It is much clearer. You can change, anybody can make a change and do whatever you like. So in that sense, Minita workspace wins. Pencil eraser are definitely quick, go to the shop and do it. Yeah. You would like to show a live demo of using it and how fast it is. Okay, so it's more like let me share my, if I have right now. So I think we are running out of time. So for any such questions, if you have related to Minitab, you have related to VSM, or you want anything on the trainings on the VSM, Nilesh is providing a training, anything, if you want any kind of training, statistical analysis, or any kind of consulting, please write to us at futureskills@datatools.me. So we will be looking at it and we will be responding to you. So because of the time, I have to stop this now. Thank you all for joining us and giving your time. It was a wonderful session. Thank you, Nilesh. Thank you for your
Thank
time.
you, Vineet.
Thanks for this session. Yeah. Thank you, everyone.
Thank you.